Hello everyone, this is Sarthak and welcome to the channel. Hope you all are doing well. Stay home, stay safe. So, I'll be discussing some questions from your PG entrance which you have recently appeared. Okay, so this will be in two parts and I'll be starting it from 31 number question. Okay, so let's just begin with the topic. I will start from 31 number question. Okay, the question says that the relationship between Cp and Cv for n mole of ideal gas is. Okay, see, from thermodynamics, for n mole of ideal gas, Cp minus Cv will be equal to nr. Okay, where R is your gas constant, okay, and Cp and Cv are molar heat capacity. This is in constant pressure and this is at constant volume. Okay, after solving this, you will get Cp will be equal to Cv plus Nr. Okay, so the correct answer for this question number 31 is B. So switch over to our next question, that is the relationship between contact angle and wettability of a liquid is. See, number 32 question. So, I want to give some basic ideas about contact angle and wettability. Okay. See, if this is a surface of liquid and this is the deviation formed by liquid, then this is your contact angle. Okay. And your wettability depends upon this theta and this contact angle. Okay, if theta is greater than 90, then this will show poor weighting. If theta is less than 90, then it will show good weighting. If theta is 90 degree, then this will show no weighting at all. Hence, the contact angle is an inverse measure of weightability. Okay, so this contact angle is an inverse measure of weightability. So for this question, your correct answer is next, the question number 33. What will be the amount of work done if 10 moles of an ideal monoatomic gas at 10 atm pressure and 27 degrees centigrade temperature is allowed to expand isothermally against constant pressure of 1 atm? Okay, so this is from thermodynamics. Here N is given, that is 10 mole, P is given 10 atm, and T in centigrade it will be 300 Kelvin in Kelvin scale. Okay, so work done for isothermal process, that is W will be equal to minus nRT ln P1 upon P2. So put the value, substitute the value here, and you will get the answer, that is minus 5.67 kilocalorie. So the correct answer for this question, this will be A, closure value. Okay, you will choose closure value. The correct answer for 33, A. Question number 34. Which of the following is not applicable to the adsorption phenomena? Okay, the options are Langmuir equation, Biot equation, Henderson equation, and Friendlich equation. Okay, so see the option number C, that is your Henderson equation. Actually, the Henderson equation are used to estimate the pH of a buffer solution. So this will not be the adsorption phenomena. Okay, so the correct answer for 13.4 is C. Okay, so the next question 35. Which one of the following terms is not associated with phase rule? Okay, this question from phase equilibrium. Triple point of water, eutetic point, and the critical point. These three are from phase rule. Okay, but the last plate point means at this point the equilibrium phase become coincident and no separation can be made at that point, which is called plate point, and this term is not associated with phase rule. Okay, so the correct answer for 35 is D. Okay, next, which of the following is an intensive property. So what do you mean by intensive property? See, the intensive property is independent of amount of substance present in the system. Okay. So specific heat is an intensive property. Molar volume, that is also an intensive property. See, all molar properties are usually intensive in nature, okay, and the surface tension also an intensive property. So all of these are intensive properties. So the correct answer for 36 is D. Okay, so the correct answer is D. Next, what is the degree of freedom of 0.1 in aqueous solution of NaCl? Basically, they have asked the degree of freedom. You know the degree of freedom F C minus P plus 2. But the answer of in aqueous solution of NaCl, this will be 1, not 2. This will be 1. Answer will be 1. Okay. So, the correct answer for 37 is 1. Switch over to our next question. What is the ionic strength of 0.2 molar of Na2HPO4? Okay, so we have to calculate ionic strength. Alright, so the formula is ionic strength of a single electrolyte will be equal to half M plus Z plus square plus M minus Z minus square, or you can write it as well like if Cij, summation of Cij. Okay, for single electrolyte. See, this is an electrolyte. If it dissociate, it will give you Na plus 2Na plus HPO4 2 minus. Okay, so the initial concentration was given, that is 0.2 molar. So this is 0.2 molar. And it dissociates into 2 times Na plus. So the concentration of Na plus will be 0.4 and HPO4 2 minus will be 0.2 molar. And the charge on sodium is plus 1 and the charge on HPO4 is minus 2. This is minus 2. Okay. So putting the value, we'll get this is minus 2 whole square. The answer will come out to be 0.6 molar. So the correct answer for this question number 38 is C. So the next question 39 number, which of the following is not the rate expression for a reaction A plus 2B gives rise to 3P? Okay, so this is the original reaction which was given in the question. Okay, so the rate expression, you know the rate expression will be minus dA by dt will be equal to minus half dV upon dt will be equal to plus 1 by 3 dV upon dt. Okay, so this is your rate of this particular reaction. So in the question, the option number 3, that is plus dA upon dt, which is incorrect actually. So this is not the rate expression, because you know the rate of disappearance, that is your rate of reactant, will always be negative, because the concentration decreases when the reaction proceeds. Okay, so the correct answer for this question will be answer C, 39C. Okay, about our next question, that is at equilibrium the process of adsorption involves. Okay, so you know the change in Gibbs free energy, that is del G will be equal to del H minus T del S. Okay, but at equilibrium del H will be equal to T del S. If this will happen, then del G must be 0. Okay, so The correct answer for this question is B. Question number 41. If molecule A absorbs light energy around 630 nanometer, the color of the solution of A will be. Okay. So the correct answer for this particular question is A. Because red light has larger waves and its ranges from 620 nanometer to 700 nanometer. Okay. So 630 comes in between this range. So the red will be correct answer. Okay. So then next question 42. The half cell A plus E minus gives rise to A minus has a large negative reduction potential. Okay. The consequence will be, see, this is your original equation. So in the above reaction, if the half cell reaction has a large negative reduction potential, okay, large negative reduction potential, then what happen, which indicates lesser tendency for reduction. So A will be easily oxidized. So answer A is readily oxidized. B is the correct answer. A is readily oxidized. Okay. So the next question, at the end point of acid-base titration involving a strong acid and a strong base, using appropriate indicator, the pH of the solution would be, see, the pH of solution would be 7 and that is neutral. So the correct answer for this question 43 is C. The question number 44. According to the transition state theory for a bimolecular reaction, the activated complex has no vibration degrees of freedom. This is wrong. Vibrational degrees of freedom, but they never participate in product formation. This is also wrong. One high frequency vibration that leads to product formation. This is the right answer. So the question number 44, the right answer is C. Okay. Next question 45. The unit of molar extension coefficient is. Okay, and this is very easy question. Actually, the direct question from your text. Okay, so the answer, correct answer for this particular question is A. Okay, the next question is, which of the following statements is correct? Okay, so the first option is wrong because helium has atomic number 2, but in question 1 is given, so this is wrong. In option B, this is also wrong because the isotope means, what do you mean by isotope? Isotopes have same atomic number, but in a case of B option, see, both have different atomic numbers, so this is wrong. But in case of C, isotones, they are isotones, and this is the right answer because isotones have same number of neutrons. How do you calculate neutrons, number of neutrons? The formula is A minus J. So K has 20 neutron and calcium has also 20 neutrons. So both are isotones, and this is the right answer 46C. Okay. So next, a molecule is Raman active if, okay, the right answer is the molecule is polarizable. If polarization or polarizability is there, then the molecule must be Raman active. In case of your vibration spectroscopy, you must have read it before that for have permanent dipole moment, it's vibrational active or IR active. But in case of Raman active, they need polarizability term or need some diffused dipole moment. Okay, so the correct answer is A. Next, 48. Cathode rays are deflected towards. Okay, you know the cathode rays are beam of fast moving electrons. Okay, which deflects toward the positively charged plates. So the correct answer will be positive electrode, not negative electrode, positive electrode. So the next question is, which is not a renewable energy? Renewable energy means you cannot use it twice. Okay, so LPG comes in that category. So the correct answer for 49 is D. Okay, the next question is 50. After bubbling air through pure water, pH 7.0, its pH decreased. Which of the following is responsible for the pH change? This is very good question. The pH value of water could drop due to reversible reaction between water and carbon dioxide, which leads to the formation of carbonic acid, that is H2CO3. Okay, so carbon dioxide is responsible for change in pH. So the correct answer for question number 50 is B. 1 number question. This is from chemical bonding chapter. Okay. So the question asked, which of the following is the correct order with respect to relative stabilities? Okay. So before that, I have to say some basics or some tricks about the stability and calculating the bond order. Okay, see, the bond order is directly proportional to stability. If I am taking, suppose A single bond A and A double bond A, here bond order is 2 and in this case bond order is 1. Okay, let it be bond order 2, this will be 1. Okay, but here the more amount of energy is required to break these two bonds. Okay, but here lesser amount of energy is required to break this bond. Okay, so bond stability basically depends upon your bond order. The more the bond order of these molecules, more will be its stability. Okay, so the trick is, if you have 14 electron, then your bond order must be 3.0. If you are moving right by increasing 1 unit, the bond order will be decreased by 0.5. If 14 electron is present, then bond order must be 3.0. If 15 electron is present, then bond order will be 2.5. If 16 electron is present, then bond order will be 2.0. Okay, remember, here one exception is there, that is CO plus. The bond order for CO plus is 3.5. Okay, so in this question they have asked you the bond stability. First, use this trick and calculate all the bond order. You will see the bond order of O2 plus is greater than O2, which will be greater than further O2 minus, in turn which is greater than O2 2 minus. Okay, so bond order is directly proportional to stability. So the correct answer for this question 51 will be answer number B. Okay, so the next question, according to Bohr's theory, the angular momentum of an electron in the fifth orbit is, okay, so according to Bohr's theory, the angular momentum, that is L, will be equal to nh by 2 phi, which in turn equal to mvr. So no need of this particular formula. Here we have given n equals to 5, so L will be n, that is your 5 into h upon 2 phi, which in turn will be equal to 2.5 h by 5. Okay, so the correct answer for this question is D. So the question number 53, in a crystal lattice, the modular constant depends on the ionic radius of the cation, ionic radius of the anion, nature of the crystal system, and the last one is ionic radius of the both cations and anions. The correct answer for this question is C, because usually the modular constant depends upon the geometry of the crystal. Okay, As every crystal has a different arrangement, so it will define nature of the crystal systems. So the next question is, which of the following is the correct order of ionic radii? Okay, this is from periodic table. Okay, so you are actually preparing for entrance. You have to attend this type of question within 30 seconds. You have to crack it. Okay, so the trick is, if you are given such type of question, just calculate the number of protons and number of electrons. Fine. Then see the attraction between them. Here 11 proton and 10 electron is present, and here 14 proton and 10 electron present. So maximum attraction will be there. That is Z effective will be higher in this particular case, and Z effective, that is effective nuclear charge, you can say, will be lesser in this case. So the order for ionic radii, if Z effective is inversely proportional to size. Okay, so Z effective inversely proportional to size. So here the order is this. So the correct answer for this question is D. So the next question, 55 number, which of the following pairs corresponds to soft base pair? Okay, so the soft base pair, the correct answer will be D. This is from your book, that is examples from your book, direct question. So the next is the ionic compound which indicates the pyrosilicate, this is direct formula. The answer for this particular question is D, that is Si2O7 6 minus. Coming back to next question, 57. The question asked the reaction of HCF6 with CSF. Cesium fluoride produces a compound that undergoes decomposition after 50 degrees centigrade. The compound is, okay, if you dissolve HCF6 with CGF fluoride, you will get yellow color salt, that is cesium HCF7. Okay, and this is stable up to 50 degrees centigrade. If you are hitting above 50 degrees centigrade, greater than 50 degrees centigrade, then you will actually get HCF7 plus CH2XeF8. Okay, and this is colorless. So the correct answer for this particular question is A, 57A. Then 58, what are the precursors used for the synthesis of borage in Stokes process? Synthesized from diborane and ammonia, B2H6 and ammonia. So this is the correct answer. Inorganic benzene, that is borage, prepared from diborane and ammonia in the ratio 1:2 at 250 to 300 degrees centigrade. Okay. Switch over to our next question, that is, which type of isomerism exists between CONH3 bromine, SO4, and these complex compounds. Okay, so these are two complexes which are given to us. So what happens if you dissociate this complex, these two complexes, you will get this type of ions. If this complex undergo dissociation, this will form this ion and this ion. If this complex undergoes this dissociation process, then it will form this particular two ion. Okay, so molecular formula is same for both the complex, but the ionization product is different for both of them. So they are giving ionization isomerism. Alright, so the correct answer for 59 question is C. Okay, then our next question, the primary valency and secondary valencies of cobalt atom in CONH3 4 Cl2 Cl complexes are. Okay, Question number 60. That is, we are given this complex. See, the oxidation state of central atom is called primary valency and the coordination number of complex is called secondary valency. So what you have to do, you have to calculate first the oxidation state of central metal atom. The central metal atom is cobalt here. So the oxidation state of cobalt comes out to be +3. I know you are able to calculate the oxidation state. Okay. So the oxidation state is +3 for cobalt. Hence the primary valence is 3. And the coordination number, see the coordination number is 6. Hence the secondary valency will be 6. So the correct answer for number 60 question will be D. That is 3 and 6. Okay. Question number 61. The rate of reversible hydration of carbon dioxide is accelerated by which of the following biomolecules? And this is obviously the answer is carbonic anhydrase. This is from your bioinorganics and this is a direct question. This forms carbonic acid in presence of carbonic anhydrase. So answer is B. So the question number 62. Okay. Among the following complexes, the one which shows zero crystal field stabilization energy is. Okay. This is from coordination chemistry, right? So if you have a little bit knowledge about the ligand field strength, then you could have cracked it, okay, in the entrance, right? So see, if carbon or nitrogen atom is present in the ligand, then the ligand is called strong field ligand, and this is a trick. You have to remember it, okay? And if oxygen and X group, that is halo group, is present, then the ligand is called weak field ligand. The difference is strong field ligand forms low spin complexes and the weak field ligand forms high spin complexes. Okay, so here oxygen is present, so this is a weak field ligand. Okay, is in +3 oxidation state. So the configuration will be T2G3 and Eg2. You know the value of T2G? It is -0.4 del naught and Eg plus 0.6 del naught. Okay, so putting the value -0.4 into 3 plus 0.6 into 2, this will be 0. Okay, so the correct answer for this question number 62 is B. Question number 63. The complex follows the 18 electron rule. Which of the following first row transition metal is present? Okay, so here it has 6 electron contribution and this particular ligand has 4 electron contribution. So this will be equal to 10 electrons. So we need 8 electron species to complete our 18 electron rule. So in case of your iron, there are 8 outer valence electrons are present. So the correct answer for this particular question is B. 63B, that is iron. So the question number 64. Here 1 mole of PtCl4 2- while reacting with 2 moles of ammonia gives. Okay. So they are giving PtCl4 2- and ammonia. Suppose I am taking 1 mole of ammonia. What will happen if I will react with this complex? This product will be formed. Okay. If I will add another 1 mole of ammonia here, then it will lead to the formation of this product, because you know the transability, that is trans effect of Cl- is greater than ammonia. So chlorine groups, that is a chloride group, direct the incoming ligand to the trans position of it. So the product will be cis PtNH3 Cl2, that is your cisplatin. And the correct answer for this question is A. Okay. Question number 65. The reaction of NaCl and K2Cr2O7 in the presence of concentrated sulfuric acid produces a vapor that turns aqueous solution of sodium hydroxide into yellow color. Okay. While treating this yellow color solution with aqueous lead acetate in the presence of excess acetic acid, it gives yellow precipitate. Okay, which of the following compounds does correspond to this vapor? Okay, this is from your transition element, and I guess this is a direct equation. So here the answer is B. The correct answer for this particular question is B. Question number 66. Okay, the number of radial nodes present in 3s and 3d orbitals respectively are. Okay, the formula for number of radial nodes is n minus l minus 1, where n is your principal quantum number, l is your azimuthal quantum number. Okay, so for 3s, 3, the greater number, that is 3, will be your principal quantum number, l will be 0, and for 3d, n equals to 3 and l equals to 2, because 0 1 2 3, this will be s p d f. Okay, so substituting the value in this particular formula, you will get this. So 2 and 0, the correct option for this particular question will be A, 66A. Okay, question number 67. Okay, the brown ring complex compound is formulated as Fe water 5NO SO4. The oxidation state of iron in this compound. Okay, they have asked to calculate the oxidation state of iron. Okay, so here you will put X, and for this is 0, and for NO this will be plus 1, will be equal to plus 2. So your oxidation state of iron will come out to be plus 1. That is the correct answer for this question is C, 67C. So the next question is, see, 68 number. Which of the following hybridization is present in ClF3 molecule? Okay, so they are basically asking the hybridization of ClF3 molecule. Okay, so we have to calculate first the number of electron pair present in ClF3 molecule. Okay, for that the trick is here, to calculate your number of pair, you have to add your number of valence electron present in chlorine atom plus number of monoatomic atoms attached to the central metal atom. Okay, so the valency of valence electron chlorine is 7, and number of monoatomic atom attached to the chlorine atom is 3. Plus 3 divided by 2 will be 5, and if there are 5 electron pairs are present, then the hybridization must be sp3d. So the correct answer of 68 number question is sp3d, that is B option. Okay, they have asked to determine all the quantum numbers of 4f orbitals. Okay, so see, in 4f, n will be 4, the maximum number, that is your principal quantum number, will be 4, and l, for 0 1 2 3 4, this will be S P D F. Okay, for F, L will be the azimuthal quantum number will be 3. Okay, then your magnetic quantum number, that is M, will be minus L2 plus L. Okay, so minus 3 to plus 3. So here in the option, there is an option that is M equal to plus 1. Okay, and the spin, if the electron revolves in a clockwise direction, then it must be plus half, and if it rotates in anti-clockwise direction, it will be minus half. So the correct answer for this question is answer number C. Okay, this is our last question, 70. Which of the following is the incorrect statement about Jesus salt? So options are A, Jesus salt is diamagnetic. This is the correct statement. So next is all platinum chlorine bond length in Jesus salt are equal. This is wrong, and this is the right answer, that is B. Because in Jesus salt there is synergic bonding. There is presence of synergic bonding. The PTCl bond length differs in Jesus salt actually. So the correct answer for 70 is B. Okay, so this was some parts of your PG entrance. I will discuss the other questions in my next video. Till then, take care. Have a good day.